let's finish this part 5 with another challenge to add this the aerodynamic spoiler on your earlier car. Let's first make this. What I will introduce is this looks like our complex formula, but you remember last part we discussed about height. It's just defined by x and y with some formula with sine and cosine. And for this, the aerodynamic, I suggest you go to this to get some the interesting understanding. It's just the al4.2.com. So from here, you can give some definition to show this one. So if you adjust this from, like this, I put this 5, you can plot, you get a different shape for this L4. And also here, you see this y formula with function to x. This is the function, the formula actually we are used here. So what we have defined is y is 5 times, actually 5 times of t is t divided by 0.2, and a0 times x is 0.5 is half, and then this is the value for a0, value for 2, 3, number 2, number 3, and number 4. So we have a 5 parameter, and this exactly coming from here. So that we call this NACA 4-digit, this Air4, the calculation. So you can learn from here. I will put this link in the video file. But from our modeling, whenever we have our the formula, actually we can build our function. So let's do this. It's NASA NACA Air4 module. So let's create, save on this. This is our part 5. So we will define this formula. So this formula is based on a function. We call this NACA half thickness is the function is x to t. So we will equal that. First is 5 times t, that is our first part, and then times, we were starting to use some more the mathematical formula, so 0.2969 is just our value, times, this is the SQRT. So that's the first part, and the minus 0.1260 times x, and then minus 0.3516 times power of x with 2, and then plus 0.2843 times power x with 3, then minus 0.1015 times power x with 4. So we make this definition. So we will use that, and then create this function called that is the Air4 module. So it's like this part, and all these are using this the airflow. So we have this airflow module, and we will make that usage is we have another the function. So second function is the NACA top. That's top one. So we need to define that coordinates. So that is T to N. So for X, so that is coordinate need to be equaled by this open bracket and close bracket. In X equal to, let's make that list generating 0, 1 divided by N minus 1. So define this, so what's the N later on. So we have this, so we have our X list. Then we create this, first is X, and Y is using the half thickness formula. Half thickness X T. So now we only have all those functions, second function now, and we will create our bottom, the coordinates. So function bottom coordinates Tn. So let's see what's the difference. So for X is the negative. So for X equal to 1 minus 1 divided by N plus minus 2, 1, and then back to 0. So that is the list. And then we have X with the minus NACA half thickness XT double brackets. So we have 3 functions here. Now we build this our final function, this big one. So function NACA coordinates COOR T to N. So what's this? Means is this one is just a concat this the top and the bottom. So concat. So what's this concat means? So let's see. So where do we have this? Not here. Here, function. So concat is return a new vector that is the result of appending the element for the supplied vector. So that's the calculation with 2 vectors. So what we will do is we will concat these 2 vectors. So what's the 2 vector is first is the NACA top coordinates Tn. So I highly recommend this. Don't copy paste. Try to key in your code by your hands. That is our practice in your day-to-day. So you know how you can make your codes key in correct. So then we have this, and we need to close this the brace. So now let's use F5. If you preview without arrow, then looks like it's that your typing is fine. And then we try to use this, and we have this module. Let's save that, and we use this as the second code. This code is small airflow polygon. Let's see how that can be generating things. So we give points equal to NACA coordinates with Tn. Then polygon points. So do we have this T and N? So let's see. Ignore unknown T, unknown N. So we don't have that the T and the N. So we need to give our value. So T is 0.12, N is 300, for example. So what's the arrow? Just the 2 arrows. So in line 9, so never fear of seeing the arrow. That is our kind of you make your code is the more correct. Ignore unknown function. So what's the unknown function? Bottom, NACA bottom coordinate. NACA bottom. So here you see I forgot our D. Then there's no arrow, and you get this coming. It's very small, but it's here. So, and also let's ensure you keep correcting your original. So I need to add this T, and these are the one. So we have this one small one. It's very small. It's just one. So if you don't zoom in, you cannot see that. And then we do this exercise and make that as a scaled. So we use this one and to save as. And now we have our number 3 scaled. So we make that bigger. So chode, we give our chode parameter. Points with NACA T is this we already have, and we make this polygon scale. So scale on the X is 20 times, Y 20 times, Z, no, just one more. Keep origin. So let's make this bigger now. That's perfect. So like this one. So we have this scaled now. And then turn above script into a modular called NACA airfold. So let's put this module. NACA airfold. And with module. And what's the parameter we will get is our T equal to 0.12, N equal to 300, and the chode equal to 20. And then let's make those 10. So T equal to T, N equal to N. And here is chode, then we don't need this anymore. So let's load this NACA airfoil. So we have this. Now if I want to see, I want N is 500, then you can get that, and the T is 0.4. You get a different kind of this airfoil. So now you can adjust this, and also the chode just 10 times, maybe 15 to get smaller. So that means this module is working, and now we we will do this this kind of the module again. So we will have this module wins, and it will use this NACA module. So then we continue to keep adding things. So that's the number 4. So we don't need this type. Then we will have spoiler wing. So we will starting to make this another module. It's NACA wing. This we will have a span, chode, TN, center, not center, so false. So we give that and have those. So let's see what we will have. That is, we will have NACA airflow, chode, TN. So we put this chode first, and we can same as this sample. Then what we will make is we can do this NACA wing is the span equal to 50, chode is 20, T is 0.12, N is 500, center equal true. So we have this here. We don't have a definition for span, but that's fine. We have this NACA, and we want to rotate. Rotate is first is to the based on X, and we rotate 90, 99. So that's coming to this direction. Then we will have that linear. So first we do the linear, then we do this rotate. So we do this to the NACA airport. So linear, that is the use this span. Center equal to center. So if that's true, then we will use true. So actually, we don't need this curly braces. Yeah. So that we have this top the spoiler wing, and then we will make that another spoiler connected with our spoiler wing. So we will starting to package our spoiler. So let's do this on the number 5 spoiler. That is our combination. We are approaching to our finished car. So we have this one. So this one is done. Then we should have another tool. So this tool is not go to the X rotate, but they just need to translate. So translate 0, 10, minus 15, and then that is our NACA wing. Now let's configure the parameter. So that is the span, chode 15, T same, they same, but they don't have the center. So let's see. You can see here. So we have this one, and we need another one. That just on Y we make a negative. Okay, perfect. It's like our expected. Then we just need to add this into our final car. So this final car you see here, module car boiler. So we will call all these as our car boiler. So let's save on this. So that is module car spoiler. Oh, we save that as NARCA. So let's save this to our NARCA CD. Then we can use this. We just use this NARCA win. So let's save that. Save as our NARCA.scad. And what I will do is, because I want to use that, so I will come to here, get this, OpenSCAD here, and use this NARCA copy and go to our library file, OpenSCAD library itself. Now we have a second library I can use. And also I will move this into our repository folder. So from repository you can get this one. Tutorial, I leave that to number 8. Then let's make our new car. So this car is a racing car. So we will open our racing car. Racing car is this one. So let's see, we draw this racing car like this. We want to add this air spoiler. So let's save that. So we have this part 5 and say number 6 is a racing car race spoiler. So what we will do is everything is can be keep no change until here. So you can put these two use together. So self NARCA.scad. So just try to use the F5. There's no arrow. Perfect. That's which means is you can now start to use that. So make this spoiler. So we will have our module car spoiler. So rotate. So this two is what we have done in the last part. Also this one. So I just copy them here, and we need to load this spoiler. So then if I come to here, so car spoiler, let's just try. So here you have this spoiler here. What we need last is just translate that to what we have is use L4 plus L5 divided by 2, then y0 is upper to 12 or 25. Let's see our last is too far away. So, no, not like L2, L4 plus D2. So that is perfect. So you can see here, it's come into here. So that is our the nice car. So I will also make, let's see, we have this 100, and then I will render this. And that with this rendering, this is the last part of the tutorial 9. With this one, let me export that. To Chapter 9, we have our finished the interesting car finally. So with all kinds of the tactics we have learned until now. And what we have going through together is all these the 9 chapters for this tutorial we have done. And as mentioned here is there's more this learning those resources. After this tutorial, I will find this some more interesting the parts in this book, which I also put here is the exercise, and every parts in this book is will be the interesting to try. And during this is I will also starting to introduce how we can utilize a lot of the library, existing library, or you can find this some other contributors to make the customized library. This is our keep learning journey for OpenSCAD because you are really enter a creative world with the things. In the last chapter, you know, is whenever you have a mathematical formula, you can make your model. So when you have the math skill, then that will be easier for you to create some interesting shape. Thank you for you to stay with me until this video, and we finish the tutorial, and we will open the more series on this OpenSCAD, and I hope to learn from you and listen to your comments, and also you can give the suggestions on which you are willing to see on this OpenSCAD, that I can make some more videos to specify your interests. Okay, have a nice day. See you later. Bye.